So it's lesson 7.1, area between two curves. Alright, let me scroll that out and get it lined up here. Okay, area of a region between two curves. Okay, so what it is, I'll try to kind of sketch it too. You're going to be integrating, because integrating helps us find area. And we'll be going like from some point A to point B. You know, integrate from A to B. And it'll have literally like two curves to look at. Maybe something like that. So the first curve I drew, I'll call that one like f of x. And then this one that's kind of like underneath, this one here, let's say that's g of x. So the goal on the assignment is going to be to find the area between those. And let's just say it is, say, like from A to B. Like, you're going to have to literally, like, they'll give you, like, the x values. Like let's just go from A to B. So how are you going to find the area between these two curves? It's not too difficult. It's going to be, you're going to integrate from point A to point B. And you'll be able to look on the graphs and figure out, like, maybe it'll be from 1 to 3, or maybe it'll be from 2 to 4 or something. You'll be able to find the points on the graphs that we work on. So you'll know where you're going to start and where you're going to stop. And now you have to pay attention to which curve is the top curve. Which one was this one? So I was trying to label it for you. This one is f of x. So you have to write the top curve, whatever it is, minus the bottom curve. That's basically how you're going to integrate. It's really not going to be that hard. Integrate from A to B. So it'll be the top curve, which is f of x, minus g of x. That's how you're going to be setting them up. So, yeah, not real difficult. So using Desmos is going to be helpful today. You can use like a graphing calculator, graphing tools to help us look at things. So let's try one. Let's say they told us to find the area of the region bounded by y equals x squared plus 2 and y equals negative x and then they put x equals 0 and x equals 1. So let's use Desmos to help us see this. Let's use like a graphing calculator. Some kind of graphing tool. You can use your graphing calculator. I'll just go to Desmos because it's right big on my screen right here. So y equals x squared plus 2 see, there's that graph, y equals x squared plus 2. And then they gave me another equation, y equals negative x. Did I type that wrong or right? Oh yeah, okay. And then they gave me x equals 0 Alright, so I'm going to zoom this in a little bit. So it said find the area bounded by these graphs. Alright, so we have a graph. The first one was this curve at the top. The second one was this black line. And then we have x equals 0 and x equals 1. Yeah, we have this x equals 0 and x equals 1, these lines. So they want to find the area between all those, like from this curve down to this line and between 0 and 1. So basically I'm trying to find the area right in there, the area of that. Get what they're saying? So see, the graphing, it helps you see it, and we can kind of shade that in. Alright, so I'll just try to sketch it on my notes then, that thing that we just used the... See, it's helpful to use graphing applications and help us see what we have to do. So x squared plus 2 was like a curve up here like this, the parabola, right? And then y equals negative x was this line down here. And then they said x equals 0 and x equals 1, like from 0 over to 1, like over to here. Just basically find the area like there. See, the Desmos helped us make it a little faster so we could see what we're doing from 0 to 1, on the x-axis. Yeah, so this parabola is the top curve, and this bottom curve down here was y equals x. Y equals negative x, sorry. Y equals negative x was this line. So what do you think? Is that okay? Kind of get how it's set up? So we're trying to find the area of this. So the area is going to be the integral from what to what? 0 to 1. And then, like I was saying, you just have to figure out the top curve minus the bottom curve. That's not too bad. Top curve is x squared plus 2 minus negative x. The bottom curve was this line, or it's not a curve, it's a bottom line, was negative x. Top function minus bottom function. It's not always a curve, it could be a straight line, Okay, so we're going to integrate from 0 to 1. Can you do, what happens when it's minus negative x? Yeah, it's just plus x. So what if I just rewrote it x squared plus x plus 2? Okay, so now we're going to integrate that. That'll give you x to the third over 3, right? And what's next if you integrate the next one? X squared over 2 plus 2x. So now you evaluate it from 0 to 1. Remember, it's f of b minus f of a. So you're going to figure out, plug in the 1 to all these, f of 1 minus f of 0. And we'll figure out the answer. Yeah, so if you plug in 1 into it, yeah, you get 1/3 plus 1/2 plus 2. And if you plug in 0 to everything, you get 0, don't you? So we just have to figure out what 1/3 plus 1/2 plus 2 is. They usually put the answers in improper fractions. 2 and 5/6, which is the same as 17/6. Yeah, the book has 17/6. So today, when you work on these, yeah, I was going to say, like, use the graphing calculator or Desmos to help you do these things. Okay, I'm going to do one more. They're all similar, they're all going to be similar like this. I'll do one more just so you see. They can get kind of, because there's some that even get trickier than that. Okay, so that's the first one. Okay, ready for another one? One more. Okay, so again, it's going to be find the area that's bounded by these graphs. Okay, so let's try another one. Let's say they have f of x equals x parentheses x squared minus 3x plus 3. And then g of x, another function, is x squared. Okay, so it's just going to say find the area. Find the area of a region bounded by these. Bounded by the functions. Okay, so again, if we use Desmos, we're going to be able to look at this and figure out where we're going. Yeah, this one they don't tell us like x equals 0, x equals 1 like the last time. We're going to have to actually look at the graph and see where these graphs like intersect each other. This time they don't tell you x values. We're going to have to figure that part out this time on our own. Yep. Okay, so I'm going to go back to Desmos again. And I'm going to type these functions in. So x parentheses is x squared minus 3x plus 3. So graphing, yeah, today you just need to use some kind of graphing utility. Otherwise, graphing everything by hand is way too tedious. I would just use a graphing calculator or a graphing tool like this, like Desmos. Okay, these graphs cross. We want to know to find the area between these graphs, bounded by these graphs. Well, these graphs, I got two colors, so that helps, the green and the blue. We're going to find the area between these right here. See that? And we're going to find the area between these. So we're going to have to find the graph points where these are crossing each other. Because it's actually two little sections where, between here, there's this little part here. We're going to find that area and the area where it's right here. So this one's like two parts. This one's a two-part one. So I can click on the graph. That's what's nice about Desmos. You can find, or a graphing calculator, you can hit intersect. I can help you with the graphing calculators too if you want to know, how do I find where these intersect? There's places where these intersect. I like Desmos because you can just click. It's easy. But on your graphing calculator, you can hit, intersect. It's calculate the intersection point. Okay, so if I was graphing it on my graphing calculator, I'll put it in. Let me delete this. Okay, so it was x. Yeah, you have to sit and punch it in. Desmos is pretty easy too, though. It was x squared. Desmos is almost easier, honestly. 3x plus 3. Okay, there's that graph. Then I have a second graph that's x squared. So I can graph those. It does the same. Here, I'll go to my camera. So I hit y equals, and I typed in these functions, the y equals, and then I hit graph, and it made the graph for me. And you can zoom in. There's a zoom button on most of these graphing calculators. Zoom to, zooms in. Well, I want to find where they intersect. So you have to hit, it's up at the top and see it says calculate. You have to hit second calculate, and then you can find intersection points, number 5. And they intersect at 0, 0. And then you can move your cursor over, you have to hit second, trace, intersect, or 5. And you have to move your cursor over where you think they're going to intersect again right here, and then hit enter. And you hit enter 3 times, then it says intersection 1, 1. It tells you that you can find them on a graphing calculator. So I can help you guys more with that if you really want to use your graphing calculator and you want to get used to using it. But the Desmos too, like I just literally had to hover over it and click on it and told me the points. So Desmos is almost easier. All right, so we got the picture. We kind of know what it looks like now. We know that they cross at 0, 0, and they cross at 1, 1. Because one of the graphs was like this, and then one of the graphs, I know it's hard to draw these things, and then one of the graphs, that's why graphing tool helps, kind of went like that. No, I'm not drawing it perfect. All right, so I'll go back to camera. So this has two parts to it. This was a tough one. So this point's 0, 0. This point here is 1, 1. Desmos tells me that. Or you can use the graphing calculator and find where they intersect. You just have to trace and find it, get to that spot. And they cross here at 3, 9. All right. So first, I want to find the area between these two right here, here to here. So I have to make an integral. Integrate from 0 to 1, right? To do this first part. Which curve's on top? This big one. And then so it's going to be x parentheses x squared minus 3x plus 3 minus the other parabola, minus x squared. That's the first piece. But then there's another piece to this. Then I need to keep integrating. I need to find the answer over here too. I need to find these areas. So what does this go from? From 1 to 3. So I need another integral from 1 to 3. I'll just put plus another integral from 1 to 3. But this time the curve that's on top is the x squared curve minus the other one. So you have to be careful and make sure you write these correctly. So I'm going to have to do 2 integrals to get this answer and then add up my answers. You can clean things up. Because I have parentheses here, you can distribute these. You don't want to have all these parentheses. So you're going to have to clean this up. So I'll rewrite it down here. So the first one's integrating from 0 to 1. And if I put that together, I'd get what? X to the third. Okay, then I have another integral from 1 to 3. And this one's x squared minus x to the third. Now we're distributing, you're distributing this minus x. So it's minus x to the third. When you distribute the next one, it's going to be plus 3x squared. And then minus 3x dx. So the algebra you're going to have to be really careful on, because there's a negative sign right here. See, it's like distributing that negative x times everything. And now, keep going. I see there's an x squared right here and an x squared right there. You can put those together. You don't have to do it. You can combine like terms before you integrate. So I'm integrating from 0 to 1, x to the third minus 4x squared plus 3x. And this one over here, integrating from 1 to 3. Let's see, I could combine some of those. Because I see x squared and a 3x squared. So that'd be 4x squared minus x to the third minus 3x dx. So you can see these problems are big. But you get the idea of it. You get how it's subtracting the curves in the picture. You get how to set them up. Because that's really, if you don't set it up right, you're lost. You get how we set it up? Maybe this curve minus that one. then integrate from 1 to 3 the x squared curve minus the other one, because this one's on top. The other one's on top. Alright, so to keep going, you integrate, plug in the numbers, and then you'll get the answer. So, we got this. You guys are doing, at least I feel like you're understanding, so I hope so. So you integrate, you get x to the 4th over 4 minus 4x to the 3rd over 3 plus 3x squared over 2. And we're going to evaluate that from 0 to 1. And then over here, if you integrate this one, you get 4x to the 3rd over 3 minus x to the 4th over 4 minus 3x squared over 2. And we're going to evaluate that one from 1 to 3. Alright, so if you plug in 1 over here, you get 1/4 minus 4/3 plus 3/2. And if you plug in 0, you get 0, right, for everything? So you can use a calculator and add up all those fractions. You should get 5/12 for this first part. Now the second one, over here you're going to have to plug in 3. This one's a little harder, so you plug in 3. 4 times 3 to the 3rd over 3. You get 36 minus 81/4 minus 27/2 minus, then you plug in 1 into all of them. If you plug in 1 into all of them, you get 4/3 minus 1/4 minus 3/2. Because I'm doing like f of 3 minus f of 1. Trying to kind of write what I was doing. That's all the steps. And you should get the answer if you do all those fractions correctly. So if I add these up, I got 9/4. This set of 3. This set of 3 over here, I got negative 5/12. But it's minus, it's f of 3 minus f of 1, so it's 9/4 minus negative 5/12. The final answer is 37/12. Yeah, so look at the workover. If you're not getting that, maybe you missed a negative somewhere. It's a lot of fractions. That's what these problems are going to be like today. Fun, huh? So I just did the 2 examples because they do take a while, but now you see how you're going to do them, how they're going to work. Use Desmos to help you so you know where to go from like 0 to 1 or 1 to 3. And we can just start working on these.